thought we would start smack on time if we could, because I feel sure that these presentations will be of such interest that perhaps we would like a little more question time at the end. In the interests of the same, I've just spoken to Jason. He tells me he's bio-agnostic. I'm not going to read the presenters' bios because I feel that between the app and the program that that you may like to do that yourself if you wish. Please know they are more than qualified to speak to each of their topics. And so I would really like to get underway, first of all, with Jason Breton today, who is the Director of Operations at Liverpool City Council. Jason tells me he's returning home. He's a Coffs Harbour boy by heart, born and bred, I think, is what you might have said, so adventuring to Liverpool. And Jason's presentation today is Councils as a Circular Economy Champion. Please welcome Jason.
Well, thanks all, and I've got the slot after lunch, so I don't really care about that either, because the people in the room today will be, not only will they be able to read about the croc and some of the things I'm talking about today, but also a special offer if you're in the mattress industry or from another council. So my topic today is Council as Circular Economy Champions. I'm not really a council guy, to be honest. I've only been at council 14 months. I'm certainly not Greta Thunberg. And my intent was not altruistic when I started some of the work around council as circular economy champions. I wasn't doing it to save the planet. I was actually doing it to make money. So irrespective of why I was doing it and looking at utilisation, I think it's important context to give you because it is about the bucks. And if it's about the bucks, it's about the bottom line. If it's about the bottom line, I can put more money back into my community and use circular economy initiatives to fund some of it. That's what we're talking about today. So obviously we understand WASM and their targets or their stretch targets about 80% average recovery rate from all waste streams by 2030. So Liverpool's approach was deliberately aligned to that policy statement. And of course, what the policy statement really talks about is not doing things ad hoc, but embedding circular economy principles into your decision making and your policies and strategies and programs. And again, when I thought about embedment, it was from a commercial terms. As being a non-council guy, I was very, very interested in the amount of assets that were underutilised at Coffs Harbour. And we have about $3 to $4 billion worth of assets, soon to be 7.8 billion when Aerotropolis comes up. So all those assets are different things, but I was really interested in utilising assets. So our approach to circular economy is aligned and in response, and it hits on the five of the seven priority areas. They're up there on the screen. So obviously meeting the waste infrastructure needs, resilience, and facilitating the transfer from a linear to a circular economy, protecting the region from waste pollution, and exploring joint procurement of waste services, something we've done quite well in its infancy. We'll talk a little bit more about some of the challenges we had and the commercial construct and the instruments and mechanisms we did. I'm a numbers guy, so I used to work for Downer in quant risk. Modelling contingency, so it's all about numbers. It's all about better decisions using data, and the numbers stack up. Even my forward projections at 33,000 units a year. I was told last year, we're just going through a budget review, guys, and they told me that we're spending 800,000 per annum dumping mattresses. Simple as that. Again, no emotion attached. I just thought that's pretty stupid, and I had a look at how much they cost to dump. And some of the alternate options around what we can do with mattresses as a single circular economy initiative. And I quickly jumped onto the mattress shredding idea through a colleague of mine, Tim Pasley at Council, who was trying to pitch it for years, but probably didn't have the influence or the impetus to get it across the line. But I think the numbers at the time were coming in at 1.6, and I thought, wait a sec, there's 2 years return on investment. It's just crazy. So I bought 2 of them. The approach was to seek forgiveness if I was wrong, rather than permission at the start. So we went to market at 1.6 and now 2.5. So we thought about the commercial return on investment to doing things like mattress shredding and acted upon it. So look, the strategy's not rocket science, guys. It's about self-performance of mattress shredding as only one, and I'll talk about what we're doing at the Circular Economy Centre at 600 Cow Pasture Road, Liverpool, and to commercialise the operations. Everything we've got, we sell halls, we sell library services, we sell childcare, and as councils, we tend to kind of leave a lot of our assets dormant. And I was looking at commercial opportunities, full stop. Again, it was the bucks. It wasn't anything altruistic. It wasn't anything environmental. It was about the bucks. And basically what we get out of a mattress, of course, is steel and flock. So the solution we thought was we collect our own and other councils' mattresses and shred them via 2 shredding machines that have been procured for operational use. The first machine is operational in September, and the second one's not January. That's wrong. We actually got it going today after some issues around dust suppression. And that's what it looks like. So we send the steel to recyclers. So the London Metal Exchange rate's $4.56 at the moment. So $4.56 a mattress I can recover on steel just by taking it down the road to the recyclers. And we also partnered with UNSW and Kang, who have passed proof of concept in manufacturing tiles. So what do we do with the flock? They mix it with 11 secret herbs and spices down at Shoalhaven at the moment. That'll soon be at Cow Pasture Road in their own manufacturing facility. And essentially we make civic quality pavers, tiles, and they've also solved the silicosis issue in relation to kitchen bench tops. The concept, the products now that they're producing out of mattress flock are exceptional. Denim jeans, used hospital gowns, all different things are going into tabletops, pavers, kitchen bench tops. Our office at 600 Cow Park, all the tiles on the floor are mattresses. I was to do the whole of Macquarie Street Mall with mattresses. I was thinking about a roof made of mattresses. I'm just going to build everything in Liverpool in mattresses, okay? If we can do it. So these exceed the Oz standards. They've been right through proof of concept. It is top quality kit that they're doing. So we've partnered up with them as a commercial partner. We'll actually manufacture ourselves using our own labour force and their IP in conjunction also with UNSW. We'll talk a little bit about that in a sec. So we're already in commercial terms. Civic quality pavers, blocks, street furniture, pavers, tiles, toilet dividers. I'm a great toilet divider expert. We spend $52,000 a year on replacing toilet dividers at Liverpool across our 217 assets. But that's an expense we don't have to do anymore. We just make them and we'll put them up ourselves. They're more robust than the ones we're using now. Seats and tables and public artwork. And again, our manufacturing process it's an integral part of our education centre because what we'll do, the kids from the local area, based on UNSW programs, will come and see how the shredding and the mattresses and how that circular economy product is made into real products they can touch and feel and take home. That's one of the presses. So we are purchasing our own press. Basically, those tiles on the left-hand side. The Reserve Bank in Sydney were pulling up their floor, but one of the requirements, because it's a heritage building, is 100% of the floor had to be reused. So they shredded them and mixed them up again, and that's the product. So they're putting them back into the Reserve Bank, top of Martin Place there. So we're looking at local jobs. We are talking to people like Soft Landing about partnering, holding hands on a few different options in relation to mattresses, traineeships, innovation, and of course it's got a direct return on investment. Again, I'm not going to sugarcoat this. It's about bucks. It's a very profitable business, and every single cent we make goes off the waste levy, which means we can forecast reduced rates. If I go into any discussion, they won't worry about whether it's mattresses or otherwise, and I go into a discussion about a forecast reduction of rates at Liverpool, they'll put a bronze statue up, right? It's unheard of, and it's a good story. It's a good story all around. It's just that this is the way we're doing it. Scale, our financial projections are based on cost to date, contemporary pricing. We've modelled the annual growth projections across what we call local mattresses, obviously in the LGA. I think it's about 33,000 at the moment. It's in excess of what we projected. Adjacent Western Sydney mattresses, that's Wollondilly, Camden, Fairfield, Campbelltown, Penrith, these kind of councils. And the Sydney Basin mattresses, we think there's about 600,000 mattresses per annum that are available to be shredded away from landfill. That is only councils. I can quote, which I won't, about 6 or 7 companies who make mattresses, some major hotel chains. They're all in the game. Some of them are paying $180 a unit to move these things. That's our croc. It was ordered from an Asian country, which I won't name, and we ordered a purple one, but it came out yellow. But that's typical of council procurement under Section 55. You rarely get what you ask for. Obviously, we had to do we worked with the EPA, review of environmental factors, and then we met with General Counsel because we were a bit worried, actually, because obviously we're a market entrant, and we have to play very carefully under ACCC rules, and obviously a new entrant to market has to be very, very concerned about how we play in that space. So we looked at an optimal commercial construct and what are the instruments that actually get us to play in that place, and protections, of course, for our commercial activities, because we're working with some pretty serious IP, guys. This stuff, these 11 secret herbs and spices are real stuff. It is a big opportunity for our partners. And also what the Local Government Act said, and the potential constraints. And I just hate Section 55, always have, and Liverpool's interpretation of it. So we'll work on that for another conference on Section 55. That'll be fun. And then we looked at potential funding and revenue application mechanisms. What are we going to do with a coin? How do we repay the waste levy for the investment in the capital equipment, et cetera, et cetera. So this is what we're offering. Against 180, 80, 65, whatever the number are, where you're doing it. This is all on a handout, guys. If you want one, they're on the chairs there as well. Take one with you. $30. $30. I'm making money at $30. You are saving a stack. Full stop. That's how it works. I'm first to market. I've got the shredders. I've got the handler. I've got the commercial contracts. It's about bucks, but it's about your bucks as well, because you will save a ton on your disposal of mattresses across Sydney or New South Wales, and we can talk to regional people as well. $40 a unit collected, so we've designed croc cages with a nice little crocodile, purple this time. They're painted purple. They're sent to your depot or any site that you want, and I think when there's 80, I think it's 80 mattresses capacity, we'll collect it and drop you a new one. So if you're not bringing them to us at 30, we'll pick them up for 40. Okay, which is still about 50, 60, 70% under market, okay? And that's free, that croc cage. So it's all the regional councils. Again, let's talk about it. There was some chat about Arana and other councils, and I don't think there's any barrier. Just do your numbers. Just do your numbers. And if it's a better number, come and see me. If it's not, don't, okay? And Liverpool is ready now. One of the things I learnt through this process is basically council to council commercial activities, you're free to go. There's no constraints. You're not required to comply with procurement constraints under 55. You can do a deal with another council to do stuff. Okay, don't worry about that. I've chucked that through external legal advice plus the General Counsel. I have no problem in explaining that to you if you are going to become a commercial partner in this enterprise, and we can work together as councils quite quickly, immediately, like let's say Monday, yeah? I think this might play if I click it again.
Hi everyone, very exciting news. What you see behind me is our new Croc mattress shredding machine. This machine, it's good for the environment because the material inside of it will be recycled. The steel will get recycled, but also all that fluffy stuff in the mattress will get turned into pavers, tiles, kitchen bench tops. And that's going to happen at our new recycling centre on 600 Cowpasture Road.
So fantastic day for Liverpool City Council. We've got 9 city councils here today from as far as North Sydney and Randwick, all looking at what we're doing with mattress shredding. Really, really proud of the team that have got the mattress shredder in operations as we speak. And this is just stage 1 of Liverpool solving Sydney's waste problem.
Absolutely, any opportunity to improve landfill diversion and the circular economy, Randwick are always looking for those opportunities.
Look, we're really excited to be partnering with Council on this initiative. Our green ceramics product, invented by the University of New South Wales, is innovative. It uses waste textiles and waste glass that would otherwise go to landfill and turns them into highly engineered, highly desirable products. For us to be turning mattresses into fantastic products like that, it's a great opportunity.
We need to make sure that we push and get recycled as much as possible. This will save money, not only for you, but for other residents in other LGAs. If those councils out there bring their mattresses to us, it will save you money and save them money. So it's a win-win for the environment, it's a win for your pocket, and it's a win for everybody.
You didn't realise you're into a sales pitch, did you? You thought you were going to some boring presentation about things. So some of the other things before, I'll just take a few questions. I'm going okay for time, am I? Okay, so what else are we doing at 600 Cow Pasture? We're partnering with UNSW. They're turning mobile phones into a very, very fine powder and then 3D printing camera cases. So you buy a camera from Canon and that's that heavy case that you see inside the box so it doesn't move. Those kind of products, they're making light switches, all kinds of stuff from very, very finely ground products. We bought a biochar machine. We'll put pallets and other stuff into the biochar machine. That cost me $4.5 million. The return on investment's about 3.5 years. Green waste plus wood will turn it into a highly potent fertiliser. We'll give 1 kilo bags out to our constituents and also flog it to other councils. Right at the moment, Dubbo are buying it from Logan, so they can buy it from us soon. And for cheaper, I'll undercut Logan, they're Queenslanders. And those kind of initiatives. We're also I've got this depot right next to the M7, if you know where that is. It's not used from Friday through to Monday. It was Oliveri's bus company. It's got a fantastic bus wash there. We're going to have tap and go bus wash there right next to the M7 using recycled water. A B-double bus wash is $380. I'm offering $250. It's got a tyre change facility at 600 Cow Pasture Road. We're going to shred the tyres. I'll do heavy vehicle tyres over the weekend with a contingent labour force or of our own labour force working some additional shifts. And again, we've got some brown water, some construction water operatives turning it into white water. So we'll use the white water to do the buses. The Circular Economy Centre will be an education centre. UNSW have PhD students and other students working on site every single day, looking at new initiatives around circular economy, and we're going to be the champions. So that's it. Okay. So I'm happy to take any questions, anything at all. Noting that I'm not, again, Greta Thunberg. I'm just a commercial guy. Thanks, guys.
Usually I'm the one that can talk a lot, Jason, so that was pretty impressive, I have to say. So very much a great start to an afternoon of innovation. And I think you might have moved on to the motivation part as well, so thank you. From local now, we're going global, and I'm very pleased to introduce Timothy Kang. And Timothy will speak to us about how can we ensure both profitability and sustainability in the recycling of waste solar panels. Thank you, Timothy.
Hello everyone, I'm Tim Kang from Hyundai Corporation. I flew the whole way from South Korea just to attend this conference. This is my first time here because I've heard that this is the place where everyone who is really invested in the recycle would attend in Australia. So this is actually a presentation about our struggle, how we ended up worrying about what to do with the waste modules. Before I start, let me briefly introduce about Hyundai in general, also our company, and then I'll move on to how we ended up doing all this. So I think you may be aware of the brand of Hyundai by the cars, but actually Hyundai didn't start as a car company. It started as a construction company. Around the time Korea had a war. In the 1950s, everything was destroyed during the war, and Korea was laid in waste. And our founder's dream was to rebuild a modern Korea, and hence named the company Hyundai, which means modern in Korea. So Hyundai Construction Company would translate into modern construction company. That was his vision. And as you can see on the screen, this would be evidence that his dream mostly came true. So in Korea, we actually have more than 100 companies using the same brand of Hyundai. It starts with the shipbuilding industry, cars, excavators, elevators, whatever you can imagine of within the conventional industries. And I'm going to move on to introducing our own company. So when I was little, I complained to God that He didn't bless Korea with the variety of natural resources that you do have here. But that secured me a job position at Hyundai Corporation, because we do not have the raw materials to build all the products in Korea by our sister companies, so we had to import everything. And then it was also a job to export everything to the global market. So that's how Hyundai Corporation started with its business. So at the end, we ended up with more than 70 global business entities worldwide. And we have been dealing with a lot of, a variety of items, including solar panels. So on the screen, you can see how many solar panels we have been trading in the last decade. So the accumulated number would reach several gigawatts. And then along the course, we have also tried operating our own solar farms. So as you can see on the screen, we operate 6 in each Korea and Japan. So it didn't take us very long until we realized that the solar panels would become a huge problem at the end of their lifespan. The reason why is, as you can see, a solar panel consists of an aluminum frame and then a glass layer. Then here you can see the blue cell layer, wherein more than 70% of its value lies in. So the weight, from the point of view of weight, more than 70% is with the glass, but the value lies with the silicon and silver. But the existence of the EVA layer, an EVA layer is a very thin, transparent polymer layer. It makes it difficult to take apart the glass and sell and recover its full value. If you could recover the full value, you could try build up a viable, economical business model, recycle business model surrounding PV module, solar panel recycle. But breaking them is a severe problem. Because of that, oh, sorry, one more slide. So here on the slide, you can see that the world is going to generate a huge amount of solar panels. This is just for Australia. All over the world, the accumulated quantity will reach, let's say, several tens of millions of tons per year. And only in Australia, as you can see on the screen, you may expect to have hundreds of thousands of tons of waste panels coming into the waste market. So the blue line represents the numbers of tonnage of modules, panels installed in the last decade. And on the right side, you can see if we assume that they all would come to the market after 10 years, 15 years, 20 years, that would represent the rest of the lines. So huge amounts. And because of that, we have been looking for solutions since over 5 years. So basically, like all other kinds of waste, you could try shred and sort them out. But as I've told you, the EVA layer makes things very difficult. So there are companies in Japan, in Europe, also in Korea, trying to come up with innovative solutions which goes beyond just shredding and sorting, like hot knife, shot blasting, pyrolysis, and so on. But most of them even fail to even scratch the surface of the essence of the problem, while some of them even ended up complicating the issue further. So that was until we encountered the company FlexRes at the end of 2022. FlexRes is a German startup And you can forget about this name, but this is a special fund where the leading German entrepreneurial families are the shareholders, like the Siemens family, the Mohn family who owns Penguin Random House and so on. They are the shareholders of this company, and this company invested into FlexRes, which is a German startup that came up with a brilliant idea how to recover the PV cells, the silicon layer from the solar panel. So unlike using thermal chemical procedures, what they do is they flash the panels with their self-designed flash lamps. So it's not a focused light source like laser, it's a light source like these light bulbs above you, but much higher in intensity. So what does these flash lamps do? So I told you that the problem is you have to remove the EVA layer to free the cell layer and thereby make things simpler. But one of the methodologies to remove the EVA layer could be you burn everything. But then you'll get to a huge amount of exhaust gas. So in case we flash it with a high intensity light source, the nature of silicon is to absorb light and turn it into either electric energy or thermal energy. That's what PV panels, solar panels do. But in this case, because the light source is of a very high intensity, it absorbs the light and turns most of the energy to thermal energy, meaning the temperature will immediately rise, as you can see on this graph. So within a dozen milliseconds, which is 1/1000th of a second, the temperature of just the cell will rise up to 600 degrees Celsius, which will be enough just to decompose the nearest part of the EVA layer. And the thickness that gets decomposed is of 1-digit micrometer, which will only release a negligible amount of exhaust gas, even very difficult to detect. So as a result, you can have the cell release. I will show you some samples of pictures later on. But anyway, what did we do after that? So last year, we spent the whole year just conducting our due diligence onto FlexRes. And on the picture, you can see FlexRes's pilot machine, which they call FlexStore. Yeah, they are Germans, so they called the machine FlexStore. And on the right side, you can see their first commercialized design of equipment. So this equipment has not yet been fully commercialized because our idea is that we could come up with something much simpler and even cheaper to resolve the problem. So this is a project that has been done in 2022, funded by the European Union, and Veolia in Germany supplied all the waste panels for FlexRes to dismantle and recover each of the components. As you can see, from 7.5 tonnage of waste panels, they retrieved all of its PV cell, solar cell, which consists of silicon and silver, that you can sell. Glass, because it is not attached to the silicon anymore, very clean, that you can sell. Aluminum, you can sell. Polymer copper. Polymer, you have to incinerate or use it as a fuel. I have to check what you can do with that in Australia. Copper, you can sell. Junction box and cable, you can sell. So you can sell mostly everything. So this has been a very successful project. And based on the outcome, FlexRes came up with the commercial design. Right now in Korea, we have imported some flashed waste solar panels, 30 pieces of them. And we are currently undergoing some tests with our largest PV recycler in Korea, what we could do with this in a simpler way. As you can see, usually you cannot rip off a solar panel because they are so robustly made. They are designed to last for 20, 30 years. But after flashing it once, you can rip off the backside. And if you open them, like a fruit, you can see all this cell layer being collected at one spot, which you cannot see with any other technology. Afterwards, everything gets very easy. You can just shred everything and sort it out, and you will end up having a very clean glass like this. I would like to speak maybe for an hour on this subject, but because I only have 15 minutes for the presentation, I'm trying to simplify everything. So, in a nutshell, yeah, the core resources that you can recover from waste panel is aluminum, glass, cell, and copper. Aluminum, cell, copper, you can not only sell, but you can even export and still make money. But the problem or homework that we have to resolve lies with the glass. I'm sure that there are solutions also for the glass in Australia, but because glass is a bit lower in value, but much higher in weight, you have to find a local solution. So you have to develop a domestic market. So I can give you a few examples what other countries are doing with solar glass. So in Korea, we are using it for flat glass production, which is the highest value market for waste solar glass. And we have also tested with the other market segment. You can use it there too. In Germany, they have not yet tested with flat glass, but they are using it for glass wool and some other usages. In Japan, they have tested everything, but they are still not using it for the flat glass. So as you can see, there are solutions out there. And we just have to find a solution for glass in Australia too. And during the conference, I've met some glass recyclers here at their booth, and I've seen that it's possible to also sell solar glass in Australia. So once we have a local solution for the waste glass, we could come up with an economically viable waste recycle solution for the waste modules with Flex Store. Right now, Flex Store is still at the stage of being commercialized in both Germany and Korea. In Germany, with the largest PV recycler, solar recycler in Germany, in Korea likewise. So it's going to take, we think, maybe a year or a bit more until we fully commercialize it. In the meanwhile, we will focus on trying to develop a market for the glass in Australia. And afterwards, we plan to approach each of the councils or cities with the problems to come up with the suiting solution in Australia. So we are not there yet, but before I end my presentation, I would like to share with you with what kind of an enthusiasm and motivation, spirit we develop our businesses. So this is the shipbuilding yard of one of our Hyundai Group companies called Hyundai Heavy Industries. This is currently the largest shipbuilder in the world, and it owns the largest shipbuilding yard in the world. So it's 60 times an Australian football yard, but you would be surprised to hear how it started. So back in the 1970s, Korea didn't have any experience in shipbuilding, but we succeeded in getting a grant from the British Imperial Bank, and we won orders for 2 vessels by then king of shipliner, the Greek gentleman, Mr. Onassis, and he ordered our first 2 vessels. So as you can see on the picture, I'm not lying to you, this is history. So the shipbuilding yard and the 2 vessels are being built simultaneously. This is a one-time occasion in history. So in the same way, with the same spirit, we'd like to build a viable business model in the Australian waste recycle market. So thank you for listening to my presentation. If you have any questions, I would like to answer them. Thank you.
G'day, my name's Peter Crace. I'm from Tomra Cleanaway, but I've worked with some solar panel waste in the past. With the flashing, do you actually remove the aluminium frame before or after you do the flashing? I'm just curious, because I'm curious as to how the adhesive around particularly the newer panels goes with the flashing process.
So before I answer, you are from Cleanaway, right?
Tomra Cleanaway, we're a bit different.
Okay, I see, okay. I really tried to get in touch with Cleanaway, but I failed throughout the conference. If somebody can find somebody from Cleanaway, please give him or her my contact point. So now the answer to your question, we can actually do both. You can first deframe or remove the aluminum frame and then shred it. Oh, your question was whether we flash it before or after deframing, right?
Yeah, and the current process, and if you do both, which one's more efficient?
Doesn't matter actually. It just has to do with the distance from the light source. So if it's with aluminum frames, then you just have to move it further up, because the aluminum frame will lift the height of the panels. If without, you just have to move that slightly down, and that can be done with some automated solutions. Automated solutions, sorry, it's not my first language, English, okay. Okay. Thank you.
So as we all know, resource recovery is, I think, the master of innovation. So we're going to move from, let's say, the hard industries to something a little more organic for the afternoon. If I may invite John. I know John well, and I'm very happy to invite him to the stage. John Vyse, who's the Director of Why Wasted, to speak about improving organics and packaging resource recovery through innovation.
Thank you very much. Oh boy, it's a bright light, isn't it? Okay, so you may notice that this is presented by John Vyse and Jimmy Jaggs. I think perhaps I'd just like to start by suggesting that Mr. Jaggs is a co-presenter for this, but he's prepared to sort of sit in the audience and take questions. As a consultant, I'm sorry. I'm just not sure which hat he's wearing at the moment, though. That's the problem. So, hang on. Where are we? So, yep, who are we and why are we here? So basically, I think Jimmy and I basically had a passion in the industry for recovery of resources, and in particular organics. And I mean, over the years, there's been a number of different sort of solutions and options, and I mean, I think I've put up there, you know, we won't mention them, will we? No. But, you know, there is a demand for resource recovery, and as Dan Nicholson said earlier on in the organics presentation, there is a demand, an unlimited demand for good quality organics out into the agricultural sector. So what we've got to do is become a bit smarter about how we recover those resources. And that really is the thing that sort of drives Jimmy and I to be working in this industry still, I'd suggest. So we've been looking for solutions, and you know, we all know that there's been a number of companies sort of come and go over the years, and a number of promises that have been made about, you know, put it all in one bin and we can recover it and we can do wonderful things for you. Jimmy and I basically came across a company in Somersby, New South Wales, and that company was established by two brothers, Ricky and Ramon Artadi, and they have developed a system which we are, I'm just trying to make sure, yep, that we are very happy to be assisting them with promoting and developing. And that really is the purpose of our talk today, or my talk today. Ramon is, I will introduce, is in the audience today. He tells me he's going to sneak away fairly quickly, but I'm sure that he would be very happy to take questions whilst he's still here. Ramon is a mining engineer, and his brother Ricky is an entomologist. And what they did was they basically put two very different skills together to come up with what we believe is a very satisfactory and very promising opportunity. So, what are ARC offering? And I think, you know, as entomologists and mining engineers, what they're offering is effectively the opportunity to capture nature and through the use of black soldier fly and combining that with engineering and effectively developing an automated system to help to actually improve and speed up natural processes. And we'll take you through what that will actually lead you to. We heard from Olympia Jago earlier on Tuesday, talking about from GoTerra and talking about black soldier flies. Black soldier flies have actually, they've been around for a long time, and they are now endemic around the world. And basically, GoTerra have been doing a fantastic job of promoting that technology, along with other companies in Australia. Bardi in Victoria, Future Green in Western Australia. And we applaud that, but the systems that they've been using effectively have been a relatively static system. And a static system, as we all know, is a limited volume system. So it is limited in terms of the quantities that it can deal with at any one time. We'll talk about that in a minute. But they do produce a valuable product. They produce valuable fertilisers, and they produce the insect themselves in terms of going into the livestock feed market. So look, I just encourage you, anybody, just do a web search in terms of black soldier flies, and you'll find there's quite a bit of information about them worldwide. The difference, though, is that most, if not all of those scenarios worldwide are static systems. So the difference really is this is an automated process. So using the black soldier fly, using nature, but effectively putting that through a process, an automated process, using drum digesters. So what does the drum digester do? So I'll just make sure that I'm in the right spot here. As you may realise, I'm not used to talking publicly, okay? So bear with me. Well, actually, I am used to talking publicly, but not with a facing audience and a light that I can't see you all. So, some of the major differences, or major hurdles, if you like, in resource recovery, which we all know about, is what we want to try and achieve is in this process effectively is the recovery of food waste. But food waste is generally attached to food packaging, and I'll show you a slide about that in a moment. And the separation of that is extremely difficult in a natural system. There's been ways of washing it. How do you recover and get a plastic packet, or plastic or cardboard or a paper packaging? How do you manage to get that clean, dry? How do you manage to be able to then reutilise that in an economic way? So cleaning and separating packaging is extremely difficult. But given the right environment, put it to you that the black soldier fly can in actual fact do that for you. And the right environment effectively is temperature, air, and a consistent feedstock. So the black soldier fly is suitable for, the larvae from the black soldier fly effectively is suitable as a protein replacement in chicken feed, fish feed. Fish meal, for example, I'll just give you an example in the poultry industry. Fish meal sells for $1,800 a tonne. Black soldier fly larvae are a direct potential replacement for that. The frass that comes from the black soldier flies, from a clean feedstock frass, which is the excreta from the black soldier fly, can or should be able to be used as a land application product, but and because it's out of an animal, out of a larvae, it actually should be able to be classified as excreta under the local New South Wales government regulations as a manure. But unfortunately, the EPA has taken a slightly different view on that, so we've got a little bit of work to do about the marketing of that material. But clean, dry packaging, we would suggest and the ARC process will provide, can be utilised into a totally new product. And then that new product is effectively as a carbon replacement into steel manufacturing, not as a waste to energy, not as a waste to energy, but as a reductant into the steel manufacturing process. So just going back a bit, packaged food waste. I mean, it's part of the problem. It's part of the problem. It doesn't matter what system you use and how much we talk about changing society, and there's all sorts of different packaging materials we're trying to use. Cornstarch bags, potato starch packaging and wrap. That's fine, but I think we all have to accept that plastic in particular is going to be around for a long time. We have no choice. In our society and in the way that we look to preserve the life of food in particular, plastic is going to be around for a long time. The trouble is, where does most of that end up? And I think we know where most of that ends up. So how do we recover that? How do we separate that? How do we change that paradigm? So, what's been proven to date? The art process, effectively, Jimmy and I have been working with Ramon and Ricky at the Somersby facility, the facility up at Somersby, which is effectively an R&D facility. It is also a black soldier fly hatchery. So what we've done is we've done some trials with food waste, we've done some trials with biosolids, we've put some 40mm minus FOGO and a combination of all of those. We've used animal waste and contaminated packaging. And the results of those trials have all sort of given us the confidence to go forward and promote this technology and take it to the next step. So what is the next step? Well, the next question is, can we use our technology in MSW? Because MSW really, as we all know, is where we've got 40%, 45% food waste in particular still present in that stream. And how are we going to recover that? Okay, there may be some panic merchants in the room that sort of say, oh no, not MWU again. And no, that's not what we're suggesting. So the answer is, yes, we believe we can actually do it. And what we want to we're going to suggest to you is that we found a partner who also shares that vision and is prepared to work with us. So we're looking to do a demonstration site, demonstration facility, and that demonstration facility in combination with our partners at Hawkesbury Council, we're looking at establishing a demonstration facility on their site at the Driftway in South Windsor, and that hopefully will be, we would anticipate or hope to be operational, Ramon? Yeah? No, end of July, early August. So that's where we would hope to be. Sam, you might correct me if I'm wrong. Samuel's in the background there if there's any questions for Hawkesbury. And look, we'd like to just say thank you very much to Sam and for his support and promotion, and also to Hawkesbury Council, obviously, for their support. So that demonstration facility, as I say, we hope to be established by July, August this year. So just quick, that's just entrance to the Driftway, and Sam has already got a pad established there for us. I'm not going to go through that slide. That's effectively for your sort of information. When you get the sort of package through, you can have a look at what a typical larger scale processing operation would look like. The proposed layout at the Driftway, will you be utilising an all-shelter building at the Driftway, 6 digesters in line, and basically a preliminary front-end sort. For anybody who's been involved in the recovery or operating MRFs or resource recovery facilities, it'll be a fairly basic front-end sort. What we'd be looking to do, though, is pull out everything all materials that effectively are non-digestible or non-recoverable. We've got to go through a fairly detailed waste management plan, as you would expect, with Council. This is going to be a 12-month trial. What it'll effectively end up being is almost a 12-month detailed audit of the MSW coming into, of 25 tonnes per day of the MSW coming into the Hawkesbury site. Now, just prior though to sort of going down that path, at the moment we have an MOU in place with Hawkesbury Council. We are in the middle of contract finalisation, and at the same time, just to make sure that everything is up and above board, Hawkesbury Council has gone through the DA process. So there is a DA that will be lodged shortly, so we'll wait for DA approval. That's just to make sure that it is all open and transparent and everybody knows what's actually coming and you don't provide any surprises to the community. So shedding is already organised and equipment list is being completed at the moment. So as I said, commencement date we hope is July, August. Now we'll run, at this point in time, the intention is to run for 12 months. And I'd have to say at the end of we have a 6 months option, I think, Sam. And we hope that somewhere through that 12 to 18 months, we'll actually be able to move to a longer term, larger scale commercial operation. That's our plan at this point in time. So, in essence, what's the process? I think, as I said, that 6 steps. So really receival, identification, isolation, bag opening. It's that front end separation, making sure that we remove any hazardous materials. Primary process, bag opening, and size reduction. Then effectively the material is fed into the digester with the black soldier flies. And the beauty of the digester and the automation of the system is effectively what you're doing is you're providing an environment which is an aerobic environment whereby the larvae can continually get access to the feedstock. What you're asking these guys to do is to actually lick and suck all of the food waste and the fats and the glues and everything else from the actual packaging material. Doesn't matter whether it's paper, cardboard, glass, preferably not, but and particularly plastic. And they do it extremely well. They do it extremely well. So then at the end there'll be a screening process. What we'll do is we'll separate the frass and the larvae for transferring off to their respective markets. But this is where the difference comes. The packaging material that has been cleaned effectively now becomes a saleable product. So through being able to put it through extrusion, we now have, through Ramon now has effectively an established market to go into steel manufacturing as a reductant, not waste to energy. And that in itself is a huge game changer, I would suggest, in this industry. If we don't do it, is that an example of what we've got? I said earlier on, and this is probably going back to the organics sort of hat, that's actually FOGO, or the waste from FOGO. You know, there's been several talks earlier on about what do you do? We're all sort of using, compostable bags. Compostable bags are fantastic. No argument. That's a good idea. Except human nature being what it is, people put other things other than compostable organics into those bags. So you've got to remove them. If you remove them, what are you going to do with them? I mean, that's a whole mixture of compostable and non-compostable bags in there, and you don't know what's in those bags. Again, so FOGO and the part of the approach that Dan Nicholson has taken in Topsoil Organics is in actual fact to pull all of that material out, and that material in itself will actually be added to some other food packaging waste, and that will go through black soldier flies. Again, what we're doing is we're recovering larvae, we're recovering frass, but more importantly, we're also recovering packaging material and plastics that would have otherwise gone to landfill. That's the difference. Obviously, through the Driftway, you know, one of the things that we will be doing, a number of things we'll be doing, is an awful lot of testing. So it won't just be effectively at least a 12-month full audit. We will be doing full analysis on the frass, on the larvae, and also sending and also testing the market and confirming the market for effectively the Syncol, which is the brand that trademark brand that Ramon has established, which is the market into the steel manufacturing business. So that's the journey we're embarking on over the next 12 months. Through that period, you know, we will also obviously be engaged with the EPA, with DPI and any of the other agencies, in fact, I mean obviously Canberra from the point of view of export, to make sure that we have all of those marketing pathways in place. So the outcome of the trial, well, you're going to get hopefully a detailed waste analysis, confirmation of process, truly transparent confirmation of process, and obviously we're hoping we're going to get the identification of process improvement opportunities, because building the first plant, it's going to be 25 tonnes a day, so about 9,000 tonnes over the year. You know, that's small scale in the overall scheme of things, but through that we hope that we can actually demonstrate the process. Confirmation of product quality and confirmation of market acceptance and uptake, and confirmation of financial viability. So that's where we're heading. And obviously, finally, acceptance from the regulators, whomever they may be, that it is a viable process and the markets are sustainable. So, outcomes, I beg your pardon, benefits. Basically reduce waste to landfill, landfill life extension, reduce cost to council and the community. Our financial modelling so far indicates that there will be some significant benefits from a direct financial point of view for council. I'm hoping that in 12 months' time we can be back here and actually telling you what those financial benefits are. So reduce use of fossil fuels, obviously significant social, environmental, economic benefits, and stop establishment of long-term viable product markets. So just like on that, I'd just like to close and say thank you very much to Samuel and Hawkesbury Council for their support. Tracy also from Penrith Council also for her support. Ramon and Ricky for their vision and their dream. And my partner in crime here, Mr. Jags, for his passion. But happy to take questions, other than from Mike Ritchie. Is he in the room? No, sorry. Sorry. No, thank you very much anyway for it. Yeah.
Segue from one landfill to another, and we're going to go up to Ipswich. So if I could introduce Sean McMahon, who's the Senior Engineer at
Cheers for that, Tracy. Yeah, thanks for having us here today. Sorry, I'm just going to try and get... Okie dokie. Oh yeah, that'd be... I really hope we get a slide going, but here we are. All right, yeah, brilliant. Cheers. Okay, so when most people think about innovative engineering, they imagine robotics or gravity-defying buildings. And in my experience, when you mention waste management at a dinner party, you don't often get the same initial excitement as these other topics. However, we in waste management have to be the dark horses in innovation as we enter an era of rapid population growth, finite landfill airspace, and hefty diversion and resource recovery targets. So while the odds seem stacked against us, it forces our industry to evolve and think outside the box to maintain effective waste management into the future. So today I'll be talking about a conceptual design for a new recycling and refuse centre and animal management facility at Ipswich to service their growing community both now and into the future. So this initial concept was created for early community engagement and feedback. So Ipswich is Queensland's fastest growing city, with the population expected to exceed 400,000 by 2031, which is about 6.5% annual increase. So the majority of this growth will occur in the southeast corner of the region. So this growth is putting increased pressure on existing waste infrastructure, which has served the city well to date, but currently operates at overcapacity. So Ipswich is proposing an additional recycling and refuse centre to better serve the needs of the growing city. So Ipswich's site selection process identified a site that, although has a long history regarding mining and geotechnical challenges, is ideal in many aspects, including the size and location, the surrounding land use, and the secondary benefit of site remediation for the council-owned asset. So in addition, a new animal management facility will be located on the site to move the facility from its current flood-prone location in West Ipswich. So the vision for the new centre is to deliver a highly functional facility that provides an excellent customer experience. The waste management component will cater for 250,000 plus visitations per year. In comparison, this is the number of people that visit Uluru each year. So the centre will prioritise resource recovery opportunities as well as residual waste sorting and transfer capabilities. And the proposed animal management facility will cater for 35,000 plus visitations per year and will provide a modern and functional centre for current and future animal management needs within the region. So during this early stage in the design, community input is vital to develop a balanced understanding of community experiences and ensure that decision making is well informed. So a traditional way to do this might be to use a combination of 2D plans and drawings and 3D screenshots or artist impressions. So to assist council and the community with this engagement process, we developed a 3D fly-through video of our concept with Infinity X visualisations. So this video isn't an additional extra, but more a new and more effective approach at the engagement process. So this method is cheaper than you'd think, so compared to more traditional methods of workshopping and preparing various drawings, sketches, impressions, and packaging and presenting this, the total cost is likely comparable. So various design components were created with a combination of AutoCAD and Civil 3D, Revit and SketchUp programs, and these were compiled into a spatial model using software called Unreal Engine, which is mainly used for making graphics for movies and video games and other interactive applications. So the model is then rendered with surface textures, light and shadows and other minor details to give that final appearance. So at this early stage in the design journey, there's a point of diminishing returns with the amount of detail displayed. So we want to provide sufficient information to engage the community and stakeholders without overcooking it with fine details that don't particularly add value at this initial high-level concept stage. So we'd save all that for the developing final detailed design flow-throughs. So once we have a model created, the next step is to sequence the video. And two pieces of information we wanted to communicate were the individual elements of the facility and traffic flows through the site. So the best way to portray this information is using interactive graphics and visuals. And another consideration is the video's flight path and viewpoints through the facility. So while we'd love to rip around and look at everything from every angle, it's surprisingly easy to make viewers feel somewhat motion sick. So the speed, simplicity of the flight path and view rotations are all considered to portray as much information as possible without sort of reaching for the tick bag. So yeah, let's take a look at the fly through. So I'll just play it for about a minute and a half, and then we might just pause it periodically and provide some commentary on the elements.
Ipswich City Council is proud to announce plans to build a new state-of-the-art resource recovery centre that will update waste management in our growing city. This development comes as a timely response to the urgent need for additional facilities in the southern region, as the existing main refuse and recycling centre at Riverview is currently operating at overcapacity. The 20-hectare site located at 831 Redbank Plains Road, Redbank Plains, has undergone extensive soil and geological testing. The site can be divided into 5 main areas. Area 1 resource recovery, including a green waste hard stand. Area 2 residual waste. Area 3 the Recycle Mart Education Centre and Council offices. Area 4 the Animal Management Facility. Area 5 being set aside for potential future expansion. Dedicated traffic pathways have been designed to ensure visits are easy and efficient regardless of the services required. The yellow path highlights the journey most residents will take when entering the site to access the resource recovery area. Red and green pathways highlight visits using the weighbridge, red for non-recoverable residual waste and green for concrete, timber and green waste. Blue pathways show the directions to the Recycle Mart offices and Education Centre, while the magenta loop shows access to the animal management facilities. Taking a closer look now at some of the site buildings. Council offices and the Education Centre will be designed with sustainability in mind, with a dedicated parking area, including solar panels. The co-location of the new animal management facility will bring a much-needed upgrade to existing infrastructure, ensuring improved animal welfare, services and flood resilience.
Yeah, pausing it there for 2 seconds. We'll first look at the animal management facility. This is purposefully located at the front of the site and with adequate distances from high-use areas on site. And the building design is courtesy of BSPN architecture, and it emphasises sustainability and energy efficiency while incorporating best practice design regarding animal welfare. So the cat kennels are designed to minimise risk of spreading airborne pathogens, while the dog kennel buildings use best practice design to minimise the stress on dogs, the barking and noise and pathogen transfer. The kennel buildings utilise single-run kennels with rear access and visual barriers between buildings. And the concept also caters for birds, poultry and small and large livestock. So in each of these, firstly, cat kennels are located in the main building here, and each of these are the dog kennel buildings. So there's 4 banks of 5 kennels in each of these. So there's a resting area at the front, and the rear is a sort of a sleeping and feeding area, and it's separated by a sluice gate in the middle, and staff will enter through the rear there. You can continue that one now. Cheers.
The Recycle Mart, or tip shop, will combine an outdoor and indoor section giving residents access to wider range of recovered materials. The resource recovery area is central to the site's purpose and Council's commitment to achieving diversion targets.
Pause it there again if you don't mind. Yeah, cheers. So the resource recovery area is also located at the front of the site, and it's before the weighbridge and paid areas on the site. And with this one, domestic customers will enter the building here and exit out here. Commercial customers will enter over this side and exit out. So the RRA design provides a hybrid style operation utilising a combination of sawtooth and flat floor bunker systems. So the layout safely facilitates both domestic and commercial customers if required. The commercial use is combined with the operational area, and both of which are separated from domestic customer traffic and reflects current best practice. So the design has the provision for small item collection, bulkier item collection, and low height grade separation to allow direct disposal of some materials. The recycle mart is also strategically located beside the RRA for efficient transfer of goods between the two. Yeah, good to keep going for a sec.
Such importance placed on getting our resource recovery right, Council will be inviting community consultation around the design and operational aspects of this area. The final area of the site involves the last resort aspect of resource recovery. The residual waste area is where residents can dispose of materials that are unable to be recovered, similarly with the resource recovery.
Yeah. Cheers. So yeah, the final area we'll look at is the proposed residual waste transfer building. So this transfer building layout is a hybrid style layout with one side of the building allocated for domestic customers and includes a recovery zone, while the other side has the flexibility to service either domestic or commercial customers depending on peak times and surges. So domestic customers will enter through this door here and tip off into this recovery zone here and then exit out this road. Commercial customers would come down this side of the building, tip off into a push pit and then exit out this road here. So the concept will allow for safe segregation of domestic and large commercial vehicles and operational equipment, and it has the flexibility to account for weekend and weekday traffic changes. There is no level difference between domestic tipping bays and the recovery zone, which eliminates fall from height, lifting, finger crush type risks that can occur with traditional transfer stations. And a mobile materials handler would then sort the load in the recovery zone and recovering what they can, and all remaining non-recyclables would then be pushed through into the push pit for transfer loading. The push pit is provided for commercial customers to enable efficient tipping, pre-compaction and mixing of waste prior to load out, and also provides some surge capacity. The building also has a suitable internal footprint to deal with future expansion or changes in operations. Yeah, keep that one rolling to the end. Cheers.
Council will be looking for community input on user experience and other operational aspects for the final design. The large grey area in the corner of the site has been set aside by Council for disaster waste recovery. Council is proud to deliver on its resource recovery strategy by providing modern fit-for-purpose waste infrastructure for residents of Ipswich.
Great. So safety, efficiency and maximisation of resource recovery are key considerations in the site layout. So the conceptual facility design will allow for separation of pedestrian, light vehicle, heavy vehicle and machinery traffic movements. It will provide separation between staff areas, customer and operational areas. It will encourage resource recovery by locating the recycling and resource recovery areas at the front of the site, so prior to the weighbridges and the residual waste transfer. And it has allowances for expansion of resource recovery activities in the future. So Ipswich Council put this conceptual design out for community engagement in August 2023 to gather feedback on what the community would like to see at the new centre. So submissions closed in November 2023 and feedback was considered as the design journey progressed. So community engagement facilitates sustainable decision making and is mutually beneficial to the community and council. Community members are best placed to identify and understand the challenges that affect them and offer potential solutions. So early engagement is essential for better outcomes because it brings diverse voices to the table to identify issues and ideas before the design progresses beyond the point that community preferences can be easily incorporated. And although this means the final design will often differ from the conceptual design, these initial conceptual designs and fly-throughs provide a platform or a basis for that valuable engagement process. So in summary, this concept design includes some new ideas and some tried and tested ones. And innovation can be both developing new ideas and taking the best of what works and not messing with it to provide safe, smooth and effective operations. This concept uses best practice design with an emphasis on resource recovery. And a picture tells 1,000 words, and I think these videos tell more again. So 3D visualizations are very effective at helping viewers understand your vision. And finally, don't underestimate the value of effective community engagement early in the design journey. So thank you for your time today. Cheers.
Emma Thompson from Scenic Rim Regional Council, and I've got a stack of questions, but I'll start with one, right? Just with the Ipswich, the design there, just wondering if you can share any changes that actually resulted from the community consultation.
I'm happy to share mine, or would you like to pop back up to the stage?
Oh, it's easy to... Oh, okay.
You've got a second mic, so that's great,
Yeah, so with the community engagement, I think we really just got some pretty just general positive feedback, like, hey, we'd love this facility, really. And it was a case of, like, we had chosen a site and it was really just saying, what do you want on it, really? And the biggest feedback was the retail markets and tip shops. Everyone was very keen for those. And I know they're one of the most expensive types of resource recovery you can do. But at the same time, in my mind, it's almost treating it like a park or another asset where it's more of a benefit to the community rather than a venture, if that makes sense. But yeah, it was really more just, most of the feedback was about things they wanted, and also examples of other sites in nearby councils areas that they liked. Like, we love this resource recovery area in this particular thing. So yeah, it was those sorts of pretty general feedback. But the design as it progressed has changed quite a lot from that, with some of those things coming in. Yeah.
Sure. This one's for John and Jimmy and Ramon. No, I don't mind who answers. Just wondering if you've got any just early stage indications in relation to volumes for what commercial volumes look like for the Syncol. Sort of thought that market's probably, that's an interesting interaction, yeah, for reductants?
Which number do you want me to quote? Look, I mean, basically the market for syn coal effectively is quite extensive. I mean, you know, come on, tell me what figure.
Well, Australia exports 300 million tonnes of natural coal.
Yeah, sorry, maybe, so what I'm asking is at what volume you would need to produce to be able to be entering that market?
Oh, you can start at a very slow, it's like finding a small coal mine and then expanding it to, we hope to achieve at least 1 million tonnes a year.
Yeah, okay.
Yeah, in a very short time.
Yeah, thanks. Yeah.
This is just an extension on from that question. With the packaging resource recovery, how's PFAS going to be sort of explored there, managed, I suppose you could say?
Basically, the information about black soldier flies, because I'll take PFAS and heavy metal, and just the indication is that basically black soldier flies will bioaccumulate heavy metals and potentially PFAS, and that'll be one of the sort of obviously the testing that we're going to have to do extensively. I mean, there are other processes that Ramon is well and truly familiar with that can actually mean that if that is where those products reside, they will not necessarily stop us being able to market those products. So there are other opportunities for production of biodiesel or bioenergy and other things. But that testing is really what we will be doing, is for both the larvae, the frass. Now, if you then come to the packaging material, and that really is the basis of your question, in the steel manufacturing process as a reductant, that's not an issue. Those at the temperatures involved in the steel manufacturing process, those chemicals will end up being probably in the slag, Ramon, and effectively the markets that we're dealing with, the slag actually has an immediate market into cement manufacture. So they will be locked up.
Mike isn't here, so I have to ask you a question on his behalf.
I knew it had to come eventually.
You can't get out of it, John. I'll be gentle. Okay. What I'm wondering is what the footprint is of the black soldier flies per tonne, or 10,000 tonnes, or 1,000 tonnes of material.
Yeah. So the area that we're operating in, or projecting to operate in, for 25 tonne a day is about 700 square metres. Now, you know, the scalability of the plant, you know, potentially we believe that we'll be able to go to 300 tonne a day. Now that is obviously, we'd need a lot of proving to be able to get to that sort of scale. I'm not sure what area we'd... 1,600 square metres. Ramon estimates that we would be able to operate that size plant in. Yeah. Is that...
Yeah, 1,600 square metres for 30...
For 300,000. Yeah. I would have thought it's a bit more than that, but I'll take...
Near enough. Come back next year.
Yeah. But we're working on within 700 square metres for the demonstration facility at 25 tonne a day. Well, nominally it's 30 tonne a day because it's 9,000 tonnes over a year. So we'll be taking about 32 tonne a day in over 5.5 days.
Any other questions? Perhaps as you do have time, yes, I am looking at you, Sam, and he's shaking his head. But,
not here.
well, I was just going to say, whether it's a black soldier fly initiative or a new facility, or maybe it's even interest in solar cells, any sort of resource recovery, we mind sharing with us what skill you undertook to convince your elected council reps to go on this adventure?
Are we still live streaming? We have built a new landfill cell and we potentially have 6 years left. So one of the options for us was to look at where we're going to from there. Really, it's just come from, we run our own waste trucks, so we already control where they go. We run our own waste facility, and this was more an opportunity to prove a concept with the executive and the elected body to see whether we can extend that 6 years out further, because we all know 2036 is coming in Sydney, so really it was trying to project forward and seeing how we could support the extension of the landfill life is probably the other thing. I mean, I'm a science engineering nerd, so, you know, this kind of stuff gets me excited too as well, right? It's a new concept. So, yeah, I think it's just bringing them along the journey. I presented to both the executive and to the elected body in a workshop to really bring them on board, talking about the maggots. So there is quite a lot of interest from our council and the elected body around this kind of project.
Thanks, and I do appreciate that you really did take that off the cuff. See, he made maggots sound really exciting, John. Yeah, maggots. BSF just sounded so politically correct. May I thank you once again. I do hope you've enjoyed the conference, as we do each year. And as I said, thank you as a great audience on the final session of today. And I'm sure that the speakers would still be available if anybody was too shy to take up the microphone. Can I ask you to thank our speakers again?